Okay, ladies and gentlemen, this is Mr. Green, and I realized that I made this class connect the other day, and after I made the class connect, I got notified that I forgot to turn on the sound. Well, there was no one there listening to me, and I was just talking away, and I didn't even recognize the sound wasn't on. Happens occasionally. When it happens, I apologize. I will redo the video, and I apologize about that, but happens every once in a while. I can't help myself. Got to make. Sometimes you just make a mistake like that every once in a while. So here it is. We're going to do it again. Where should you be? You should be finishing Unit 1, not having anything to do with in Unit 1. And then we're going to be starting looking at Unit 2, which is a graphing type of a unit. So what I want to do today is a little bit of a review of Unit 1. So when you get a question like this one, it says calculate the length of side B to 2 decimal places. The whole concept here is knowing those sine functions. If you're given an angle in one side, that's all you've got to have to get the sine functions. Sine functions. Sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. SOHCAHTOA. So that's all you really need to have to be able to do these things. So what we can say is that the sine of 27 degrees is equal to b over 30. So what we can do is just do a little bit of cross multiplying, and we get 30 sine 27 degrees, and that's what b would be equal to. And then all we have to do is, after we calculate it, is round it to 2 decimals. Okay, calculator's not running like it was when I did my class connect, so I'm going to have to start my calculator up. It takes just a second or two to get started and running, and then we can actually work this out. See, TI Smart View, it's right there, starting up. Okay, there's my calculator sliding in there from the side. So I'm going to take 30 times the sine of 27 degrees, and I hit enter, and I'm going to get a number of 28.69. One thing I didn't do was I didn't check to see what mode I'm in. I'm in radians. Okay, I want you to notice that I recognized I wasn't in the right mode right away because that number was way too big. I was expecting that number to be a lot smaller than that. Okay, so I come back over here, and I'm going to put it back into degrees here, and second quit. And I'm going to do the same thing again. 30 times the sine of 27 degrees. And I hit enter, and it is 13.6. Well, to 2 decimal places, that'd be 13.62 would be my answer there. So that would be equal to 13.62. Okay? Now I want you to notice that when I did that with my calculator, how did I know the difference between 28 and 13 would be wrong there? Well, the sine of 27 is nearly 30 degrees, and that the sine of 30 degrees is like 1/2. So I wasn't expecting this to be anything more than 1/2. So I was expecting a number somewhere around 15. That's the way you can use these sine functions to make certain you're getting them. Okay? Okay. The legs of a right triangle measure 6 and 9 units. Well, that means if I've got a right triangle, I might as well just draw a little right triangle here. Right angle there, and a triangle like this. And the legs, well, the legs are these sides here are 6 and 9 inches. If the angle between the 6-inch leg and the hypotenuse, and that's what we're trying to find. This is theta. That's the one we're trying to find. Well, you know what? We know that the tan is equal to the optan of theta would be equal to the opposite, 9, divided by 6. And that's what we can use. We can say that theta would be equal to the tan inverse of 9 divided by 6. And that shouldn't be a problem. We just come to our calculator. We press second, tan, 9 divided by 6. And what we'll get is a degree measurement of, come on, give it to me, 56.3 degrees. Okay? So they're wanting us to find what is the sine of theta. Well, the other thing we can do here is we can say the sine of 56.3 degrees then is equal to what we're looking for here. So sine, and we just stick that number in there because it's more accurate than what my 56.3, and I get 0.83. Okay, you see how I had to go back and read the question because they were looking for the sine here. Another way you could have done this, okay, you could have said, well, 6 squared is 36, 9 squared is 81, so that we know that this long side over here, C, is going to be equal to 8, 9, 10, 11, 117, square root of 117. And the sine is going to be 9 divided by square root of 117. I just want to see what I get when I do that. So I'm going to take 9 divided by the square root of 117, and I should get 0.832050294. Look at that. Every single digit matches this one right up here. Isn't that amazing? That's what the power of the calculator is. I didn't even have to do the Pythagorean theorem or that division to make it work out for me. Cool? Okay, moving forward. The angle of elevation to the top of a 20-story building. Here's my tall building right here. Is measured to be 10 degrees from my point on the ground. So here's a point. This point is 1,500 feet from there. Okay, and this angle of elevation here to that up there is 10 degrees. Okay, find the height of the skyscraper. Well, I've got this side, and it's this one we're wanting to get. That's a tan. Tangent of 10 degrees is equal to the opposite, x divided by 1,500. So that means that the x is going to be equal to 1,500 times tangent of 10 degrees. Well, let's just work that out real quickly. 1,500. You got to push the zeros. Thank you. Tangent 10 degrees. And see what we get when we do that. And we got 264.5. Wasn't dyslexia kicking in there? Nope. 264 and a half. 264 feet high. Okay, it's a 20-story skyscraper. I just wanted to know, if I divide that by 20, that means that each story in the skyscraper is 13 feet. That makes sense, doesn't it? Has to be a little bit taller than the normal human, plus a little space for wires and ceilings and differences between floors and things like that. So 13 feet per floor makes perfect sense, doesn't it? That's the way it figured out. Okay, let's move forward. Which of the following could be right triangles? There's a lot of ways we can do this. One of the easy ways of doing this is with the Pythagorean theorem. Okay, so 2 squared plus 3 squared equals 4 squared in a Pythagorean triangle, right? In a right triangle. So that means that 4 plus 9 would equal 16. No, that's not true. Let's try this other one. 6 squared plus 8 squared equals 10 squared. Well, that's 36 plus 64 equals 100. Yes, that would work. Okay, let's try this next one. 8 squared plus 15 squared equals 17 squared. Well, that's 64 plus 225 is equal to, I don't know my 17s. I'm sorry. 17 squared. 289. Let's see here. 9, 8. Yes, that's true. So let's look at this last one. 7 squared plus 12 squared equals 13 squared. Well, that's 49 plus 144 is equal to 169. And that is a 1, 8. No, not true. Do you see how I did each one of those with the Pythagorean theorem? That's how you can say whether they're right triangles or not. Okay, if t is any real number, what is the possible values of sine of t? Or is it possible that the sine of t is equal to 0.3 and the cosine of t is equal to 0.48? Well, let's just look at this. If I drew a triangle like this, and it's a right triangle, and I'm calling this t. Well, this side over here, the opposite side, divided by the hypotenuse, is going to be 0.3. So O over H equals 0.3. And this side, the adjacent side divided by the hypotenuse, A over H, got it right on the board, equals 0.48. Now, since this one has 2 decimal places and this one only has 1, I'm going to add a 0 here just to make them the same. Okay? So now I've got a 0.3 and a 0.48. You know what? One of the ways that makes this work is if I have 30 divided by 100 and 48 divided by 100. Now, it doesn't matter how big the triangles are. These ratios work all the time for these angles. So I could actually say, well, what if h is equal to 100 and the opposite is 30 and this side over here is 48? Then I could use my Pythagorean theorem. 30 squared plus 48 squared is equal to 100 squared. Well, I can't do that in my head, so 30 squared, 48 squared, and if I add those together, plus 900, I get 3204. So if I take 100 squared, I do not get 3204. So the answer would be no, that would not work. Okay? And that was just using a little bit of logic and reasoning to work that out like that. Okay? Are there other ways of doing this? Sure. Why, certainly there are. Because we know that the tangent would be 0.3 divided by 0.48, right? What is 0.3 divided by 0.48? And we get 0.625. Well, you know what? I don't think that's the same as 30 divided by 48. Oh, it is. Wow. Oh, that's what I did. I divided 30 by 48. Duh. Okay. So that way it actually looked like it might work, but if we use the Pythagorean triples here, we can see it doesn't make a right triangle, does it? This is the way I would have done it. This is the way I did it the first time when I recorded this lesson, so just do it that way. Okay. Dr. Black is standing 25 feet from a street lamp. This is where I drew a street lamp. Okay. And I drew a picture of Dr. Black over here in his little beanie hat. Okay. And it says that he's casting an 8-foot shadow. So here's the little shadow of Mr. Black here. It estimates that the angle of elevation from the tip of his shadow to the top of the street lamp is 20 degrees. So that means it goes through here, through the tip of his thing like that, and that's 20 degrees. Okay? And they want to know how tall this street lamp is. Well, this is 25 feet, and this is 8 feet here. So from the tip of the shadow to the street lamp is 33 feet. So what I could say is that the tangent of 20 degrees is equal to the height of the street lamp, which is what we're trying to find out, divided by 33 feet. And when I multiply this out, I'm going to take 33 times the tangent of 20 degrees, and we get 12.01. We get that x is equal to 12.01. That means that street lamp is about 12 foot high. I buy that. Looks like a good answer to me. Okay? So the secret word for today was ski jumping. If you watch this video, you'll be able to hear it this time, and you can just tell me the secret word for today is ski jumping. Okay? I appreciate you guys telling me that you're in pre-cal every time you send me messages. It really helps. I'll talk to you next time.